Hello, we are going to discuss about room temperature control. In this video, we are going to talk about a control system for controlling the temperature in a room. So what is temperature control? You can guess the meaning of it literally that it is the controlling the temperature parameter of a system. So what actually is done is that detection of temperature change of a system can be done and also the components of it. Also, what actually happens is the passage of heat energy entering or exiting the system can be adjusted to achieve the average value of the desired temperature.
A thermostat is a component of a control system that senses the temperature so that it can be maintained around a near desired set point. Here we are using a thermostat to control the power supply of a solenoid. A bimetallic mechanical sensor senses the air temperature using differential expansion of two metals to actuate an on-off switch. Typically, the system would be turned on when the temperature drops below the set point and turned off when it rises a few degrees above to avoid excessive switching.
So first of all, we would be discussing about the open loop implementation for controlling the temperature in a room. For this purpose, we generally have a device known as room radiator. Along with this, we have a valve which would be controlling the amount of steam flowing into the radiator. Also, we have a boiler which would supply the all steam required for this purpose. Now, based on the input given by the user, the particular temperature would be set for the room. Based on this input received, the valve would control the amount of steam flowing into the radiator, and based on this steam received in the radiator, the temperature can be achieved in the room. Apart from this, there can be various disturbances in the radiator arising because of the outside temperature or the surrounding environment.
The circuit that you are seeing here is an example of on-off controller, also known as bang-bang controller. This can be used to control the temperature of the room. In this circuit, the power resistor is the heating element. If the temperature of the room is lower than the reference temperature, power resistor would be conducting and the room would heat up. And if the temperature of the room is higher than the reference temperature, power resistor would be switched off and the room will cool down. The way this circuit works is as follows. Depending upon the temperature of the room, thermistor would have different resistance, and depending upon the resistance, the different amount of current would flow from 5 volt to ground. This would imply that there is different voltage at point A in this circuit. We can set the reference temperature through the voltage at point B. Depending upon the difference between the voltage at point B and point A, the op amp would either saturate to plus 10 volt or minus 10 volt. Depending upon whether op amp saturates to plus 10 or minus 10 volt, power amplifier, the MOSFET that is in the power amplifier part would either be conducting or would be switched off. If the power amplifier is conducting, the power resistor would get some finite voltage across it and it would start heating the room, and if the power amplifier is switched off, power resistor would also be switched off and the room would not get heated. So if the temperature of the room is higher, power amplifier would be switched off, and if the temperature of the room is lower, power amplifier would be switched on.
The principle of operation of the temperature control system is that the actuator which contains the solenoid and the steam valve is made to operate according to the sequence in which one of the two possible situations specified here has come about at a given time. In situation 1, the controlled variable T assumes a value below the desired temperature T dash, or in other words the error E, which is the difference between the desired temperature and desired temperature T dash and T, is positive. In this situation, the solenoid is in energized state and the steam valve is open. As T gradually increases, the error E also decreases. In situation 2, the control variable T assumes a value above the desired temperature T dash, that is, the error E is negative. In this situation, the solenoid is de-energized and the steam valve is closed. As T is gradually decreasing, the absolute error is also decreasing. This happens because of the heat transfer from the room to the colder surroundings.
As we saw the open loop implementation for controlling the temperature, now we would look at the closed loop implementation for better control of the temperature of the room. Now based on the input given by the user, it would be set to an appropriate value through an adjustment mechanism which would be sent to a thermostat or a switch. This thermostat would be either operational or not operational at a particular state of time. This will send a current signal to a solenoid. and this solenoid, if operational, would open the valve for the steam to pass onto the radiator, and this radiator would then start the heating process for the room. Also, there would be various disturbances that could creep into the systems because of the temperature difference in the environment around the room. And finally, we would have the temperature control in the room. To have a continuous and effective temperature control, we would take temperature feedback using a thermostat, as we have already discussed its functioning in the previous slides. And these thermostats feedback would be fed back to the thermostat switch, and based on this feedback received, the current signal can be modified and a better control could be achieved.
Hope you liked our video. Thank you.